Hi guys, welcome back to the channel. In this video we are going to discuss about types of counters. So there are only two types of counters, that is synchronous and asynchronous. So we already discussed about basics in this introduction to counters. In this video we are going to discuss about elaborately the difference between both of them and major things or other types of synchronous and asynchronous counters in this video. So let's get started. So let's have a quick overview. So in the counters we have two parts, synchronous counters and asynchronous counters. So in the previous video we have discussed in brief. So in this video we are going to discuss here detail. So what is meant by synchronous counters? So synchronous counters are nothing but just the changes in the clock signals. That's it. So just the basis of clock we can decide is a synchronous circuit or asynchronous counter. So if you see here the clock is same. Clock is applied to all flip flops at a time. It might be any of the flip flop. In this case I took D flip flop. So this is containing three flip flops. So this can be considered as 3-bit synchronous counter. Synchronous clock is applied at a time to all. If you see a synchronous counter, then you can also observe a simple difference. That's it. It's not much changes. Only clock will change. That's it. If you observe here, the clock is changed as. So in the previous case, we have clock is applied at a time to all flip-flops. But in this scenario, we are going to apply the clock from the previous output. If you see the second D flip-flop, we are taking clock as previous output. If you take the third D flip-flop, we are taking the clock as the previous output. So like that, how many flip-flops we have to connect in this fashion. So this is known as 3-bit asynchronous counter because we have three flip-flops. So it can store 3-bit of information. And the clock signal is asynchronous. That is why it is known as 3-bit asynchronous counter. I forgot to mention this is also known as the ripple counters. So this is very important. Ripple counter or asynchronous counter, both are same. Based on the previous video, we can classify all the counters in these types. So the first one is asynchronous up counter. This is normal type. Asynchronous down counter. So we also discussed what is meant by up and down. So up means nothing but we are going from 0, 1, 2, 3 like that, or we are going to start from any of the random to going top. So down counter also like that. We are going to suppose start, example I started with 8. So 8, 7, 6 like that I have to go. So synchronous up, synchronous down. Asynchronous up down means in a single circuit, single asynchronous counter, we are going to have an up and down as it is. So in the upcoming video I am going to start asynchronous circuits only so that you can understand the basics of asynchronous counter very much well. So I am going to build the circuit, the 2-bit, 3-bit, 4-bit and all things I am going to build so that you can understand. So you can have, means in the same circuit we are going to have up down. So synchronous up down counters also we are going to have. So asynchronous random counters also we are going to have. Basically it will count any random sequence that we want. So at first video only I said that we can build whatever logic that we want. We can build whatever circuit, whatever sequence we want, we can build that. So we can build the synchronous random or asynchronous random counters also. So let's see a quick overview of up down and some random sequence orders. So if you see up counter, if you start from 0 end with 3, you are going to continue the same sequence. So 0 1 2 3 0 1 2 3 like that you are going to follow. This is known as up counter because we are starting from low and going to up. So if you see from the down counter, we are going to start from 8 2 and end with 0, and again we are going to follow the same sequence. So I hope you know that. So some random sequence counter means you are going to have some any sequence that you want in your mind. So I started with 5 2 6 1. You can take anything. So again the same sequence we are going to follow, that 5 2 6 1. So that kind of counter we are going to build. So how to build, that and other things we are going to see in the upcoming video. But just remember some random sequence also we can build, but some logic. We are going to understand the main differences between asynchronous counters and synchronous counters. So this is the circuit diagram that we already saw, but this here representation in 2-bit. But any of the bit you can take, any number of flip-flops you can take, join in these formats, they become asynchronous and synchronous circuits or counters. So now let's discuss about the main important points or definitions of the both ripple counter and synchronous counters in the point format. So if you observe the ripple counter, that is the flip-flops are connected in such a way that output of the first flip-flop drives the clock of the next flip-flop. So if you observe the circuit diagram, you can able to understand very much well. We also discussed in the circuit diagram of ripple counter. In the previous output will be influenced the next clock. That's only we had saw in the circuit diagram also. So the synchronous one, not like that. Clock is applied at a time. So if you see the point also, there is no connection between outputs of the first flip-flop and clock of the next flip-flop. So whole clocks will be triggered at a time. So the next point, if you observe in the table of ripple counter side or asynchronous counter, flip-flops are not clocked simultaneously. You already know that. So the previous previous output will be clocked to the next flip-flop. So that is the thing that we have saw in the ripple counter. But in the synchronous counter, if you observe, the flip-flops are clocked simultaneously. So this is the important point. The next point is circuit is simple for more number of states in the ripple counter. Yes, of course, because the previous output is just going as clock, it is very simple to connect all the previous ones to the next ones. So it is easy because increasing number of states. But in the asynchronous counters, we are going to have many number of wires and much more circuitry, more complexity will be involving over there, because each and every line has to be drawn up to the last flip flop. But in the asynchronous one, it is no problem because previous one is just connected to the next one. But here synchronous one, you have to drag all the way clock, and we are going to pass we are going to have some propagation delays also in this synchronous one. So if you observe the next point, speed is slow as clock is propagation through number of stages. As we have the different number of logic gates inside each and every flip flop, so the propagation delay would be very large if you go up to the last flip flop if you go in the ripple counters, because previous output. So we are going to wait for the previous output to the next clock. So that is the reason it is slow somewhat as compared to synchronous. But synchronous, there is not much problem because clock is not waiting for the previous output. It just triggered at a time. So high speed will be there in the synchronous one. So in the previous one, I said propagation delay means in the sense means it has to travel in up to the whole way, but it is very fast as compared to a synchronous one. So the next and foremost very important point in this difference is, in the asynchronous counters, we need to understand that operates only up and down counters only. I repeat, asynchronous counters can operate only up counters or down counters. But whereas if you consider the synchronous counters, in the synchronous counters, we can have any kind of operations we want. We can have up counters, we can have down counters, we can have the random counters. But in the synchronous counters, we do not have, or we cannot form the random counters. We can only form in the synchronous one. This is very important. Because if your teachers or lecturers means in the exam, they might ask you form this random sequence. They might ask form this like I want 2 4 5 1. This form this sequence. So you can only use the synchronous counters. You cannot use the ripple counters to form that sequence. And finally, if you observe the examples of the both ripple and synchronous counters, so in the ripple counters we have examples, that is ripple up counter, ripple down counter, or asynchronous up and asynchronous down counters. We can also have both of them at a time and in a single circuit. So if you consider in asynchronous counters, the example or ring counter or twisted ring counter, it is another name called Johnson counter. So we will see these two circuits or counters in the upcoming videos. So if you want more detailed tabulated form, so this is the thing that you can have a screenshot. So these are more elaborated thing, but the differences that I have taught up to now is much more important, or that's enough I think. So if you want, take this also. All the points are same, but one or two points might be added here. I hope you understood the differences between both of the types of counters. In the upcoming video, we are going to have started with asynchronous counters. We are going to build, or we are going to have the logic of 2-bit, 3-bit, 4-bit asynchronous counters. So stay tuned. Thanks for watching up to now.